Welcome back. So in our 7th tutorial video, we will be learning about something based on numerical method, namely Gauss Elimination Method. Now what is the purpose of this Gauss Elimination Method? The Gauss Elimination Method helps us to find the numerical solutions of a system of linear equations. Suppose this is a system of linear equations formed with 3 equations. Now, as you all can see that these 3 equations have 3 unknown terms, that is x, y and z. In Gauss Elimination Method, in order to find out these unknown terms or unknown variables, 2 major steps have to be taken. What are they? Firstly, it is elimination, and second, back substitution. So let's start with elimination. In elimination step, what we have to do is firstly create an augment matrix. Now, what is an augment matrix? An augment matrix is a matrix which is formed with the help of all the coefficients of the unknown terms, and as you all can see that the last column of the matrix contain the right hand side of the equations which form the system of linear equations. For example, if we take the first equation, then the coefficient of x is 1, coefficient of y is -2 and coefficient of z is +9, and the right hand side of our equation contains 8. Now let's go back to the augment matrix. Just see the first row having 1, -2 and 9. Those are the coefficients of the variables, and the last column of the first row contain 8, that is the right hand side of our equation. Our next job is to eliminate certain coefficients from the matrix. Okay, we will eliminate the coefficients from the matrix in such a way that the resultant matrix looks similar to an upper triangular matrix if we do not consider the last column. Then the matrix which will be formed is an n into n matrix, and simultaneously it will be an upper triangular matrix. So now there can be a question that why we will form an upper triangular matrix. In Gauss Elimination Method, back substitution is a major step. So in back substitution, what we do is we proceed from equation 3 to equation 1. So from equation 3 we find out the value of z, hence the 2 coefficients of the other 2 terms should be eliminated, so that we are left with only the z term. In a similar way, we have to make the 3 equals to 0 or the coefficient of x equals to 0, so that we are left with only 2 terms, that is the y term and the z term. The y we will find out by substituting the value of z which we have just found out. And in the first row of the augment matrix, no elimination is required because we have the value of y, we have the value of z, only we do not have the value of x. So we can substitute the values of y and z in order to find the value of x. Hence, if we consider the resultant matrix, it will be just like this. Cross symbols indicate that there will be some value, and 0 are marked in their desired positions. Now let's concentrate on how to make an upper triangular matrix through row operations. We have to make the 3 in the second row equals to 0. How is it possible? That is, we have to make a of 2, 1, that is the position of 3, equals to a of 2, 1 minus something. so that our result will come as 0. The value in this question mark have to be a of 2, 1. Then only we can make the result as equals to 0. How can we do that? Just see this. With the help of a variable c, that is possible. If we take a variable c such that c is equals to a of 2, 1 divided by a of 1, 1. What is a of 1, 1? A of 1, 1 is the element just above 3. And then if we multiply this c with its denominator, then what happens is we are left with only the numerator. And as you all can see that the numerator is a of 2 and 1. Now place this value in the question mark area, you will finally get a 0 in the position a of 2 and 1. Now as we have to perform similar operation to all the elements of the particular row, hence what we will do is we will take the next element of the row, that is a of 2, 2, and we will perform a similar operation. What's that operation? We will take the a of 2, 2 value minus the c into the element which is just above the element present in a of 2, 2, that is the element present in position a of 1, 2. Similarly, we will find out what will be our final value in position a of 2, 3 and a of 2, 4. Hence, after performing all the row operations, we obtain this final resultant matrix. Now let's see the code and understand how to make such a upper triangular matrix. Firstly, you see we have declared a float type of array, A, which is our augment matrix. C is the term which we have already seen. What will it store? Now you see that we have entered the order of the matrix and so on. We have entered the elements of the augment matrix. Now our aim is to make an upper triangular matrix, and you see now this J is our column and I is our row number. So the operation will be performed only when I is greater than J, and we have seen that C should be taken as A of ij divided by A of jj. Now as the operation has to be performed throughout the row, that means the column will keep on changing for each of the elements. That is performed by another loop or another loop variable, which is k. Just see this, the I which we are using in C of A of ij divided by A of jj, the similar I is being used in the left hand side of the equation as well as in the right hand side of the equation with the first term, and k is these terms and the j is used over here. Similarly over here, okay, so we have made an upper triangular matrix. This is another for loop which will show us the resultant upper triangular matrix. Now let us move on to our next major step, that is back substitution. I have previously said you all that in case of back substitution, what we have to do is we should proceed from equation 3 to equation 1. At first we find out the value of z in equation 3 by eliminating the x and y terms. Then in equation 2 we eliminate the x term, place the value of z in equation 3, and finally we find the value of y, and finally we determine the value of x from equation 1 by substituting the values of y and z which we found out in our previous two steps. After we have done that, the final system of equations is this. So just see, we have back substituted and firstly we found out the value of z, then y, then x. So what are we doing actually? Firstly, we are adding left hand side of the equals to sign except the variable term, and then finally that result we are negating from the right hand side of the equations. Let X be another array which stores the solutions, that is the values of the unknown terms. Namely, x1 will store the value of x, x2 will store the value of y, and x3 will store the value of z. At first, we will find out the value of xn, that is, in our case, as we are using 3 variable terms, our xn should be equals to x of 3, which will be equals to a of n plus 1. This indicates the last column element of the last row, that is the right hand side of the equation, divided by a of nn. What is a of nn? A of nn is the coefficient of the z. For finding x of n minus 1, that is y, we first need to negate all the terms other than y in equation 2 from the right hand side of the equation, and finally divide the result with the coefficient of the unknown. And this process will continue until and unless we reach the first element of x, that is x of 1. After we have found out x of n, that is the variable present in the last equation, then we enter into the nested loops. And in the nested loops, as you all can see, I iterates for n minus 1 terms, and it is iterating in a reverse order, that is n minus 1, n minus 2 up till 1, because we are performing back substitution. So we have found out xn, then now we have to find x of n minus 1, then x of n minus 2 until we reach x of 1. The J loop helps us to sum all the terms other than the variable term. A of ij is the coefficient into the value of the unknown term which has been recently found out by us. So we find out one term, and if there are more than one terms except the unknown term in the left hand side of the equals to sign, then we have to sum up them all at first. So J loop performs that operation. After we are done, we come out of the J loop and finally calculate the value of the variable. Okay, so x of I stores the value of a variable term. How to find that out? We have to negate the sum which we obtained in the J loop from the right hand side of the equation. So clearly this one, a of I and n plus 1, is the right hand side of the equation. We have to subtract this and the sum which we obtained from the J loop, and finally divide that sum with the coefficient of the variable a of ii. This nested loop helps us in back substitution. Now we are done with all of our operations, so we will print out the solutions as desired. So now let's run it and see. GCC Gauss Eli.c. Yeah. Now it's asking us the order of matrix. Let us consider the example only 3. Now it is asking us to enter the elements of the augment matrix. As it is a float type, we will have to write the values in this order. So just see, the upper triangular matrix is as follows, and the solutions are x equals to 1, y equals to 1, and z equals to 1. So you all can try with more examples, and this code will definitely give you all the correct answer. If you all like the video, please don't forget to like it, share it, and to keep updated with the latest videos which will be uploaded, please don't forget to subscribe. Thank you for watching.